So we're taking our notes in your notebook today when they're going to be titled Lesson 6.5. And in Lesson 6.5 we are multiplying polynomials, just like we started in yesterday's homework. And we're going to be multiplying for a little while here, but today what we're going to do is we're going to take a monomial times another polynomial that's not a monomial. So when we are multiplying a polynomial by a monomial, I want you to write this in there, multiplying a polynomial by a monomial, we're going to do distributive property, and we know how to do that. You just have to distribute that monomial over all the terms of the other polynomial. So when we're multiplying a polynomial by a monomial, we're going to do distributive property. And remember, distributive property is really multiplication over addition and subtraction. So it's how we get rid of the parentheses. So these problems actually come from, I'm not going to make you open your book, but these problems actually come from page 423 in your books, the check it out problem. Okay? So why don't you just make reference in your notes that this is where the problems came from. If you want to reference them, so on page 423, and the first one that we're going to do is known as 2a. So we're going to do the monomial 2. What kind of a monomial is that? What kind of a polynomial is 2? It's a monomial, but what's its degree? It's a constant, isn't it? Yeah, it's a constant. And we're going to take it times 4x squared plus x plus 3. So our first factor is a constant monomial. What's our second one? No, what's the 4x squared plus x plus 3? Degree?
Quadratic.
2 quadratic. Trinomial. So here we have a constant monomial being multiplied by a quadratic trinomial, and we're just going to have to do, because there's only one term in the factor out front, so we're just going to do distributive property. So in our notes, let's just, at least for this one, I don't know, I want you to see that what's really happening here are 3 multiplications, right? 2 times 4x squared.
8x squared.
Plus the 2 has to get multiplied times the x. Plus the 2 gets multiplied by the 3. So we really have 3 multiplications here. Now that's monomials times each other, like you did for today. What's 2 times 4x squared?
8x squared.
8x squared. Plus
2x.
2x.
Plus 6.
Plus 6.
That's it.
Does it need any cleaning up?
No.
Okay, so if it doesn't need any cleaning up, then are there any terms that can be combined?
No.
No? Do you think we're done? Yes, we are. That's it. That's our answer. That's our product.
When we show this, do we have to do, like you did 2.4, or 2 times 4x squared, you know? Like how you did that?
I won't make, you're talking about this step right here, right?
Yeah.
No, if you can do the multiplying, you've done enough distributive property, you're successful, you can skip that step, yes. It's okay. Okay, here's the step we're not going to skip though. If there's subtraction, what are we going to do? Change it to add the opposite. Okay, so let's do 2b. We have 3ab is our monomial. that is going to get multiplied times the 5a squared plus b. This one might be worth not skipping that multiplication step. It might be good to see our 3ab being multiplied by 5a squared plus our, so right here we're taking the 3ab times both of these terms. So now we also have to take 3ab times b. This one is worth writing down, and I want you to. Before, when we were just taking that simple monomial 2 times it, that was pretty easy to do. Okay. In reality, we could even show one extra step of work here. We could rearrange this so that the things that could be multiplied times each other or beside each other. We could rearrange the multiplication. This would be the step I'll let you skip if you think you can do it without it. Okay? But in reality, we can rearrange it. Let's put together the things that can actually be multiplied times each other. That one didn't really have to have anything rearranged. So what's our first multiplication end up giving us?
15.
15. A to the what? Third. Because remember there's an invisible 1 there. So 1 plus 2 is 3. And B. Okay, there's that one's product. Plus 3. Have anything to be multiplied by? No. A got anything to be multiplied by?
No.
No. A B times a B is?
B squared.
B squared. Not 2b, but b squared, right? Okay, now let's look. Do you think those are like terms? Can they be combined? How do we know they're like terms?
One has a fact.
Okay, they gotta have the same exponents and on the same variables. So if this one had a cubed on the A and didn't have a squared on the B, would they be like terms then? In other words, these parts have to match exactly. They have to be identical twins. If they're not like terms. So we would stop right here and say this is our answer because there's no cleaning up to do either. So the step that the step that has the arrow by it, that's the don't have to show step. We don't want to. The step above it in red. Do I want to see that? Yeah, I do. Okay.
So you don't? Never mind. I don't know what I'm doing.
Okay, where did you get lost here?
No, after that step that you circled, I added them all.
You put them together and got 18?
Yeah.
Okay, why can't we do that? Okay, can we add x squareds to x's? No. Can we multiply? Yeah, we can multiply x squared and x, but we can't add them. Okay, so in other words, they have to, the variable and their power have to match exactly. So, Chelsea, does a cubed b match ab squared?
No.
No, it doesn't. That's why we couldn't put it together and make it 18. Okay? Okay, it's a good question because it's tempting to do, isn't it? Okay, let's do 2c, which is 5r squared s squared. Not a fan of when they use s, but they did. And then r minus 3, not r, s. Make your s little enough that it doesn't look like a 5. If you make it too big, then that's when you might mistake it as a 5. Okay. There's subtraction here, isn't there? So what are we going to do? We're just going to stay in the habit of changing subtraction to add the opposite. So it's going to become 5r squared s squared times r plus negative 3s, right? Okay, now we're ready to do our distributive property. This has to be multiplied times both of those. So 5r squared s squared times r plus 5r squared s squared times what? Times what?
3x.
Ne-
Times
negative
negative
3s. Okay, what do you want to do next?
add the variables.
Okay, should we rearrange?
Oh,
5, that's the only constant in this one. We're doing this multiplication right now. We're just rearranging it. R squared times R times S squared. And remember, when you're rearranging, just remember algebra likes things in alphabetical order, right? R's come before S's. So since algebra says, you know what, keep them in alphabetical order. And then this one we have a 5 that can be multiplied times a negative 3. We don't have any other R's except that R squared. We have an S squared, and we have an S. So again, all we did was rearrange. So we have a multiplication here, we have a multiplication here. So what's our first product going to be?
5r cubed.
5r to the what? Third power?
And then s to the
S
second.
squared. Those s's don't have anybody else to be multiplied by. Plus
Negative 15
negative 15
r squared.
r squared. That doesn't have anything to be multiplied by.
3 to the third.
S to the third.
Just kidding. I meant s.
My S got a little bit big there. Okay. Are those like terms? What do you think? Are r cubed s squareds the same as r
No.
squareds s cubed?
No.
No, they aren't, are they? Okay, so all we have to do is clean it up. Cleaned up, 5r squared, or cubed I mean, s squared, minus 15 r squared s cubed. And that's our final answer. So any part of that we need to go back to and talk about. Okay, we're going to do one more. Because they have this one where they have a monomial times a monomial, and then that is times a binomial. So we need to know how are we going to handle a problem like that when we come across it. So we're doing actually problem number 12, and I'm going to guess this came from another page. This is actually from page 427, the homework page. Okay, so let's do, it is 5m squared, n squared, oh no, n cubed, sorry, times m n squared, and then behind that is 4m, take away n. Okay, I just want you to analyze this. I don't really want you to start doing any writing yet. What do you think would be our first move in this one?
Change subtraction to add the opposite.
Okay, we could change subtraction to add the opposite. I'm just going to do it right in here, right now. Then you have to write that all over again because it's a lot to write. Okay, next. I think it would be the next move.
I'll take the 5 times any other.
No, wait a minute.
No, you don't take.
There's an addition problem going on, and out front of it, when there's something out front of it, that means it's being multiplied by something.
Multiplication first.
So, do we want to take care of this multiplication first, do you think?
Yeah.
Yeah, let's take care of that first. Let's get that cleaned up. Let's get that simplified. And then what that monomial becomes is what we'll distribute with. Okay, so we need to take this monomial times this monomial before we do distributive property.
So when it's mn squared, does that mean the m is squared and the n?
Nope, just the n is squared.
Oh, okay.
So we have a 5 times an m squared times an m times an n cubed times an n squared. We're just rearranging that. We're just trying to get that one simplified. So what's that become? 5m to the third power,
Plus n to the fifth.
not plus,
Just n.
n to the fifth, right?
Yeah.
Okay, so that becomes, so now what we're going to do is we're going to say, okay, this needs to come down, this needs to come down, and we're going to write that problem with it being, now that we've done that first multiplication, we have 5m cubed, n to the fifth, times 4m plus negative n. So all we did was take care of that multiplication, get that simplified. Now we can do our distributive property. So now we're going to take this monomial times those two pieces of our binomial. So we have 5m cubed n to the fifth times 4m. That's our first arm, plus 5m cubed n to the fifth times negative. What number do you think we should stick in there behind that negative sign?
1.
1. Let's make that a negative 1. We got to deal with that negative. Okay, now we have this multiplication to do, and we have this multiplication to do. Go ahead and do those and see what ends up happening. Haley?
I wrote mine differently.
Can we wait then and see if we get the same answer? Are you done? You have it all the way down to an answer?
No, I'm following you, but I'm just writing it different.
Okay, so tell me then, how did you write it?
Well, I just separated all the numbers and
Oh, you rearranged right away? In the step, you mean? Okay, I guess I'll have to see it. Okay, so if I do the rearranging step, I have m's come before n's, and
yeah, that's
constants come before variables. So there's a rearrange step. If you need to disagree with me at any point, change my mind about anything I might have done wrong. Are they like terms? Are m to the fourth, n to the fifth the same as m to the third, n to the sixth? Are they like terms? Do they match?
No.
No, they don't. So now I'm going to just clean this up, right? 20m to the fourth, n to the fifth. Take away 5m cubed, n to the sixth. Anybody get that answer? Yeah? Yeah, a couple? Yeah, good. I didn't want to have to start it over. I'm hoping I was right. And I trust that you guys are, so. Okay, anybody have any concerns anywhere along the way in this? Typically they're like this, there just might be one or two of them that are in your homework, I don't know exactly, but typically it's just a monomial that doesn't need cleaning up first, doesn't need simplifying first before you have to distribute.